foundation of modern civilization is electricity. We run our appliances, our computers, our entire lives off this vital resource. But how does it even get to your house or apartment? While solar panels and generators allow individual homes to generate their own power, for most people around the world, they rely on electricity being brought to them through power lines from power plants, either renewable or fossil fuel. Transmitting electricity for one house can be done through just a small wire, but when you have to transmit electricity for an entire city, it requires incredibly thick and large high-power transmission lines. These massive lines run at high voltage, upwards of 500 kilovolts, with thousands of amps, often hundreds of feet up in the sky, to keep them away from people. High-voltage towers are essential to powering the world and transmitting electricity over great distances. So how are they made? These high-voltage lines consist of massive metal towers that are firmly bolted to the ground. Notably, these massive towers aren't often built in place. Rather, they are moved into place utilizing large helicopters, which is quite the sight to see. The towers that are built on site out of lattice structures tend to be slightly weaker than the much stronger towers moved into place. A typical tower can be anywhere from 50 feet tall to even more than 1,200 feet tall. The towers are generally spaced between 1/8 of a mile and 1/4 of a mile apart, depending on how high of voltage the lines are. When the voltage is lower, the towers must be closer together so that the voltage can be boosted using different electrical equipment on the towers. In higher voltage, the towers can be spaced further apart as the electricity needs less amplifying. These towers aren't cheap either, coming in at about $300,000 to $500,000 per mile on the low end, to even upwards of many millions of dollars per mile for standard high-voltage transmission towers. Attached to the towers are the transmission lines, or the wires. These wires are massive and carry so much electricity that if left uninsulated, they would ionize all the air around them and form a path to ground, causing massive amounts of damage. This means that the wires have to be connected to the tower utilizing long chains of insulation. As for the wires themselves, their size will get larger as the voltage they need to carry gets larger. As a wire undergoes larger electrical load, they can begin to heat up, causing the metal to expand and the wires start sagging. Engineers need to account for this in their design, so the sagging transmission lines don't fault on trees or structures underneath. With all of that said, these massive electrical towers are fairly simple in their overall operation as described. Once the transmission lines get to their destination, say a city, a large step-down transformer is used to lower the voltage and push it out to houses and buildings in a usable form. These transmission lines have to stretch great distances, further than you might imagine too. The longest high-voltage transmission line in the world is currently in Brazil. The Belo Monte Rio de Janeiro transmission line stretches a whopping 2,543 kilometers, carrying 800 kilovolts of direct current from the 11.2 gigawatt Belo Monte hydroelectric power plant nearby. While the longest transmission line, it isn't the one with the tallest height. That record goes to the Mount Demotion Transmission Tower in Zhejiang City, Zhejiang Province. It towers 370 meters into the sky and is the tallest transmission tower in the world. These massive transmission towers are vital pieces of infrastructure engineering. They have to endure extreme weather in remote environments, carrying one of the world's most important and vital resources to populations around the globe.